Radar is a detection and ranging system that transmits radio frequency pulses to objects, receives the reflected signals, and uses them to determine the target's range, angle, and velocity. Radars are used to detect aircraft, ships, spacecraft, guided missiles, motor vehicles, weather formations, and terrain. In traditional radar systems, in order to obtain high-resolution range estimation, a large bandwidth transmit pulse is required. Such transmission demands a high sampling rate receiver, which is both expensive and power-consuming. An available alternative is to employ sub-Nyquist radar systems. These systems combine the knowledge of the transmitted pulse together with the received signal model to enable low-rate sampling. In practice, however, the transmit pulse may be distorted or changed during transmission due to weather conditions, making sub-Nyquist systems inapplicable. In this demo, we introduce a sub-Nyquist radar system with unknown pulse. The system utilizes additional low-cost and low-power receivers that operate at sub-Nyquist rate. By using results from sparse multi-channel blind deconvolution, the system produces high-resolution target detection without knowledge of the transmitted pulse shape.
In this demo, we consider one transmitter and two receivers. To generate the transmit pulse, we use a signal generator where a pulse of 1 MHz is generated. To generate the received signal, the transmit pulse is passed through a fading simulator where we added time delays as well as the amplitude fadings. Received signal from the targets is passed through two received antennas, RX1 and RX2. Both the received antennas have two channels. One operator's Nyquist rate of 1 MHz and another operator's sub-Nyquist rate of 100 kHz. Once the signals are received and samples at Nyquist and sub-Nyquist rate, they are passed through a system. At the system, we combine the signals from the two channels and apply an iterative algorithm to estimate the time delays and the amplitudes.
To conclude, both the sub-Nyquist system with a single receiver and the featured systems with two receivers sample at 10 times below the Nyquist rate, and both systems have comparable performances for different noise scenarios. But while a sub-Nyquist radar assumes that the TX pulse is known, the featured system does not require TX pulse knowledge.